Hello everyone, my name is Sudipto Mitra and this is Nitish Ramchurn. Both of us together we will discuss about implementing the VMware NETLAB setup on a single blade system and eventually calculating the total energy consumed by the setup on the blade server. Now a quick background of what we are trying to do. Now we are trying to implement the NDG NETLAB setup on a blade server. The NDG NETLAB, they are an organization that allow academic institutions to host their IT equipment remotely. So it doesn't matter where you are in the world, you can still get access to the IT equipment. Okay. Now NETLAB, they have different academic courses. So they support VMware, Cisco, EMC. And today we'll basically look at, or we'll basically try to implement the VMware NETLAB setup to do the labs. There are 23 labs in total. Okay, this topology is the topology that we're trying to implement for the labs. Okay. So as you look in the picture here, we have got ESXi 1, ESXi 2. Now ESXi is a software that helps us to create a virtual setup or a virtual network or virtual environment. So as you see, you've got your ESXi, and on top of that you have some virtual machines which are running on the ESXi. Then we have a SAN. A SAN is a storage area network, and it's basically a collection of hard drives which is used to store data or store virtual machines in this case. Then we have your vCenter, VMware vCenter. Now VMware vCenter is basically a management console from where all the virtual machines can be accessed and controlled. And we have a vClient, VMware vClient. vClient basically allows us to access specific virtual machines remotely. Okay. And as you see, each machine, ESX and the SAN, they've got about 2 or 3 virtual NICs, and the vClient and vCenter, they have got 1 virtual NIC. I'll give a quick review of the blade server. Now, that one there is a blade server. Okay. As it says, it's a small self-reliant server rack mounted in a special enclosure called the chassis. So this one is the chassis, and at any one time, the chassis can hold up to 8 single blade servers. Now the blade servers, they don't have a power supply or a cooling mechanism or management console. All that is provided by the chassis. So that one there is a cooling fan. This particular blade has got 6 cooling fans. And that one there is the power supply. And this particular blade has got 4 power supplies. And all networking services are achieved by installing PCI Express cards. And each of these blades, they have a hard disk, but any additional space, or there is a special service called storage service where you can install additional hard disks. Now for the objectives of the project. First step, we are going to install a storage server to a blade and configure a SAN, a storage area network. And to configure the SAN, we are going to use a software called OpenFiler. Then once we configured the SAN, we're going to set up a virtual environment on the blade. So we're going to install a few ESXi instances, and on top of that we'll install some virtual machines. And finally, we will calculate the power that is consumed by the blade setup and compare it with a few other different types of setups which we have tried. Now the physical topology, this is what we were using. So here we have got the blade, okay, and the storage, and on top of the blade we have an instance of ESXi installed, which is ESXi3 as we have called, with the given IP address. On top of the ESXi, we have installed two more instances of ESXi, called it as ESXi1 and 2. We have installed OpenFiler to help us create a SAN, and we have installed the vCenter, which is the management console. And on the ESXi, we have installed some virtual machines, mainly XP, to do the practical labs. Okay. Now, all these machines, they were accessed from a vClient, which was installed on a laptop, and the laptop was connected to the blade server using a Cisco Catalyst switch. This is a brief summary of the hardware that we were using. So the blade has an Intel Xeon processor, has got 6 gigs of RAM, one 160 GB SAS hard drive. On the storage blade, we installed two 72 gigs SAS drives. Laptop, the hardware configuration of the laptop, AMD Phenom, 8 GB of RAM, and we were using a Cisco Catalyst 2960 switch with 24 ports. Now for the logical topology of the setup. So here are our physical devices. So that's the blade server, that's the storage, and the vSphere client. And on the blade, we installed ESXi3, a bare metal installation of ESXi. And on ESXi, we have installed ESXi1, ESXi2, installed OpenFiler and configured a SAN, and we have installed an instance of vCenter 4.1. Okay. And we have set up a few virtual network cards, so the devices could talk to each other. To configure the storage blade, the server blade and the storage blade, they have to be placed in even and odd numbered bays. Now what does that mean? So this is an example of the chassis, and this holds, as I've mentioned previously, holds 8 blades, up to 8 blades. So the numbering starts from the bottom, so 1, 2, 3, 4, 5, 6, 7, and 8. So if you want to install a storage blade, the storage blade has to be put in an even numbered position. Storage blade has to be put in an odd numbered position. So for this, so you could use 1, 5, 7, or 3 to configure the storage blade or install the storage blade. And you could use 2, 4, 6, or 8 to place the blade server. Now for our labs, we've used slot 7 and slot 8. Slot 8 had the storage blade, slot 8 had the blade server, and slot 7 had the storage. Okay. And as I've mentioned before, there were two 72 GB hard drives that were used for the storage array. And when the blade was accessed from the management console, we could see that 7 and 8 were mapped, as specified here. Okay, and when we started the storage blade, we can actually see the hard drives that we were using. So we were using 2 hard drives for the storage array, and we made that into one logical drive, as you see here. Okay, now I'll quickly go through some of the issues that we faced during the implementation of the setup. The first issue we faced was we could not connect the chassis to the internet, or we could not connect the blade server to the internet. Okay, and that was particularly crippling because we could not install NTP, DHCP, or the DNS server. So to get around that problem, what we did was we installed OpenFiler as a virtual machine on VMware Workstation, and then we basically converted it and transferred it to the ESXi3, which is the bare metal installation on the blade server. Now once we did that, we still had some problems. We did not have any network connectivity, and the Ethernet NIC cards changed their name from ETH01, ETH02 to 3 and 4 respectively. So to fix that problem, we enabled Ethernet 3 and Ethernet 4 cards from the command line, and we changed the MAC address in the network configuration script to match the MAC address of the virtual NICs. Once we did all this, we managed to run OpenFiler without a problem. Now the next problem we faced was, because we were running multiple instances of nested virtual machines, the nested virtual machines could not communicate with each other. So to allow the nested virtual machines to communicate with each other, we had to turn the promiscuous mode on. So to turn the promiscuous mode on, we had to go to Configuration, Properties, vSwitch, and basically accept the promiscuous mode. And when we did that, all the virtual machines could talk on the virtual network. Okay. Right, then we had, again, because we were running multiple instances of nested virtual machines, all the virtual machines were not turning on when we were turning on the vCenter. We were turning on the ESX. So to do that, we had to expose the NX or XT flag, also called as turning the long mode on. Okay. So to do that, we basically had to go to Options, Configurations, and add a row with monitor_control and .restrict_backdoor, and put the value, set the value to true. And then we set the CPU MMU virtualization to hardware CPU and MMU. And once we did that, we could turn all the nested virtual machines on without a problem. Now, this error, okay, let me quickly explain what we're trying to do here. So we installed an instance of XP on ESX, okay, and then we were basically trying to use that virtual machine as a template and trying to install this virtual machine on other ESX. But when we tried to do that, we kept getting this error. Now we are not really sure why we kept getting this error, because we were using legal copies of XP and we were using legal licenses. But in spite of that, we just kept getting this error. So we went to C Documents and Settings, Crypto, and we basically removed the temp file. once we did that, we could install XP, okay, but the installation was only valid for 30 days. Now again, a similar issue cropped up when we are trying to hot clone the XP machine. Again, we are not really sure. So we went to the C drive and changed the permissions to full control. And once we did that, we could manage to hot clone the virtual machine. So for some reason, this particular instance of ESXi and VMware vCenter don't like XP. Okay, then we had VDR01 power on error. Now this one, VDR01, is a data recovery appliance. And when we tried to run the VDR01, which is the data recovery appliance for one of the labs, we had a power on error. The main problem was we were trying to run, the appliance was a 64-bit operating system, and we were trying to run a 64-bit operating system in a nested virtual environment. So once we moved the appliance to the bare metal ESXi, we could fix this problem. And this was the final lab. Now here we were trying to configure VMware high availability. Now VMware high availability is basically, if you remember at the topology, we had two instances of ESXi running. So by configuring VMware high availability, if one of the ESXi machines suddenly stops working, the virtual machines will be transferred to the other ESXi. That is basically what VMware high availability is. Okay? And we faced this problem because we had some configuration issues and we couldn't test the final lab. Now we believe that installing additional RAM, now if you remember, we were only using 6 gigs of RAM in the blade. So by installing an additional, just to be on the safe side, additional 6 gig of RAM, I think we could have fixed this problem as well. Okay. So we could successfully implement 22 labs, sorry. And on the 23rd lab, we just couldn't implement the lab because we just did not have enough hardware to support. Now I'll hand over to Nitish to explain the power consumption.
Thanks, Sudipto. Yeah. Nowadays, when we talk about green IT, we cannot go about and not talk about virtualization. Virtualization has taken the industry by storm in the past few years. It is mainly because it can reduce the operational cost of our entire IT infrastructure considerably if implemented correctly. When we started with our academic project, we were very curious about the energy consumption of our VMware labs. So we wanted to see if the energy saving can be made on a small scale. The fact that we were using a blade server which is designed to consume less power, it should also reduce our energy consumption even further. We measured the energy consumption using energy meters. We measured the energy consumption of the same VMware lab setup on different hardware to do a comparative analysis. In the first setup, we used two PCs which are like your everyday personal computer and implemented the labs on VMware Workstation. The second implementation was to implement the labs bare metal on the blade servers, and then we did the same lab but we virtualized all the lab on the same blade server. And finally, we tried to compare it with an estimated equivalent rack server energy consumption. First, let's see the implementation of the blades without virtualization, which is the bare metal implementation on the blade server. As you can see on the diagram on the right, which is the VMware lab setup, we have 5 physical servers. So on the blade system, each blade server on the blade system represents 1 physical server. And in this setup, over 13 sessions of 5 hours, we found that the energy consumption for this setup is 25.7 kilowatt hour per lab setup. Next, we measured the energy consumption for the lab setup on 2 PCs. We used 2 PCs because each PC on its own could not run the lab setup due to the limited amount of memory. And in this setup, the consumption was around 12 kilowatt hour. Now for the virtualized lab setup. Important to note that in this setup we run the whole lab setup on a single blade. The 5 physical machines required for the lab setups were run virtually on a single blade. That is the beauty of virtualization. It allows us to run many virtual machines on few physical servers without compromising on the performance, and often virtualization offers many other advantages. Also important to know is that running a single blade server on a blade system is not efficient. To see a major reduction in energy consumption, a blade server must be run with at least 3 blade servers. So we ran 4 complete lab setups on 4 blade servers, which is equivalent of running 20 virtualized servers on only 4 physical servers. And on this setup, we consume around 8 kilowatt hour, which is considerably lower than the non-virtualized lab on the blade server. Finally, we compared the virtualized blade implementation with the equivalent rack mounted server implementation, and the estimated power consumption for the rack mounted servers is 10.2 kilowatt hour. Then we compiled all the data and produced bar chart, and it shows the energy consumption for each environment in kilowatt hour, the energy cost, and the consequent CO2 emission based on the average CO2 emission per kilowatt in Victoria. And in this chart you can see that it clearly shows that the virtualized blade server consumes less power. This slide shows the bar chart on the left shows that a comparison between the non-virtualized lab and the virtualized lab, and you can see a drastic reduction in energy consumption. It's around 67.3%. And under the bar chart on the right shows the energy consumption between the rack server and the blade system, and the reduction from the rack server to the blade system is around 20.5%. We can see the reduction in energy consumption and CO2 emission, but it might not be economically feasible for some businesses to implement such measures because the investment costs of this technology are quite high. This is one of the main flaws of our economic system. It cannot put a value on the environment. The next bar chart shows the investment costs and the operational costs of each setup. The blade system has many redundancy features, which makes it a very reliable piece of hardware. The redundant cooling and power system alone are a big feature in the blade system. Also, according to HP, the blade system uses 30% less power to its equivalent rack-mounted server, and also 40% less space than its equivalent rack-mounted server. It is also optimized for power saver by placing unused power supply in standby. It also doesn't need external cooling. It can operate at high ambient temperature compared to its rack-mounted counterpart. And now I will hand over to Sudipto for the conclusion. Thank you.
Thank you, Nitish. So in conclusion, I would like to say that we successfully managed to implement the VMware NETLAB infrastructure on the blade server, on a single blade server. We successfully managed to connect a storage blade and implement a SAN on the storage blade. We still need to do some research about the deploy template error. As I've specified before, we were not really sure why we kept getting that error consistently. We were using legitimate copies of Windows XP and legal license keys. We believe that a volume license key might fix the problem, or had we used Linux instead of XP, that might have fixed the problem. Then we had the high availability error. Now the error was caused mainly because there were no free resources. More specifically, we had used up all our memory. So we believe that installing additional memory would have fixed that problem as well. And the blade server actually consumes more power for a single lab setup, but when you run multiple VMware NETLAB setups on a single blade, and each blade can support up to 4 lab setups, the power consumption is reduced. Okay. So before I finish, these are some of the references that we used over the course of our project. And before I finish, I would like to thank a few people. My colleague Umesh, who helped us with the video. Our course coordinator, Dr. Jan Newmarch, who allowed us to work on the blade server for the project. And Mr. Frank Mentiplay, who patiently helped us with some of the issues we faced during the course of the project. Thank you very much for listening. Thank you.